Hello there. My name is Shannon Keene. And yes, it's pronounced Keene. I'm a senior cloud advocate on the enterprise platforms and tools team at Microsoft. I'm here today to talk through the next evolution of the Azure VMware Solution, or AVS for short. For additional content as time unfolds, please feel free to connect with me on Twitter or LinkedIn as AVS continues to gain popularity with our customer base. Also, the aka.ms link showing up on this slide will take you to the brand new documentation for AVS. At the present time, AVS version 2.0 is GA and deployable in East US, West Europe, and Australia East. Let's move into the introduction and background. So let's talk a little bit here about how you can run your native VMware workloads in Azure. So the AVS delivers a comprehensive VMware environment as a service, which allows customers to run native VMware workloads in Azure. Customers can now migrate VMs directly from on-premises environments to Azure, landing on bare metal, purpose-built, hyper-converged dedicated nodes to run your VMware VMs in Azure in the hypervisor you love and know on-premises, VMware. Customers can now seamlessly run, manage, and secure applications across VMware environments in Microsoft Azure with the common operating framework. Customers will be able to capitalize on existing VMware investments, skills, and tools, including VMware vSphere, vSAN, and vCenter, while leveraging the scale, performance, and innovation of Azure. There are some new and differentiated features related to this version of AVS. We had a 1.0 offering, and things have changed ever so slightly. So first things first, AVS version 2.0 is a first-party service certified by VMware. Then there's this seamless Azure experience and native integration that should hopefully shed light where everything you need to configure happens in the same portal you would use for any other Azure service like a VM or a web app or Azure SQL. Companies can make use of the hybrid use benefit licensing for Windows servers and SQL servers, which reduces the operational capex or the operational costs. Then, if you are still running Windows Server 2008 or 2008 R2 or the SQL versions of both flavors, you are eligible for the no-cost extended security updates in Azure by using AVS. Patching your environment becomes more cost-effective by migrating these VMs to Azure using AVS. Big plus. If there are issues with your AVS environment and you need to escalate with support, you only have to call Microsoft. You don't need to flag both Microsoft and VMware. Microsoft will then coordinate with VMware to resolve any issues you may face with your AVS environment. The AVS environment supports the latest VMware technology updates, so this helps you continue to move the mark forward and ensure the software you're using is supported within the lifecycle management ecosystem of both Microsoft and VMware. The Hybrid Cloud Exchange, or HCX, Enterprise Edition is available, which helps you migrate those VMs from on-premises into Azure using Vmotion, the technology I think every VMware administrator absolutely loves. Our AVS nodes are fast and highly performant using a hyper-converged infrastructure as well. Then there's a concept of a unified licensing and consumption using the AVS solution in Azure, which makes cost optimization and usage easy since you're only really going to one spot to grab all of your info related to cost. There's also a simplified NSX interface using AVS version 2.0 as well. In terms of the software and hardware package, everything is listed here. These specifications will evolve and change as time marches forward, but at the present time, having all of this sit in your AVS version 2.0 means you gain access to all of these features outright. Billing uses an hourly pay-as-you-go model, and you could also consider using reserved instances, either the 1 year or the 3 year. The service requires a minimum of 3 AV36 nodes, and you can add single nodes as required. These are the common use cases or scenarios we tend to see. In terms of the data center expansion, reduction, or retirement, you can gain additional capacity when you reach the limits of your existing data center thresholds. It's also easy for you to add needed capacity in the cloud and eliminate any headaches or managing any hardware refreshes. Customers can reduce the risk of cloud migrations by using AVS compared to the sometimes time-consuming conversions or re-architecture when you move to IaaS or PaaS. Plus, you're using familiar VMware tools and skills to accelerate those cloud migrations, which helps. In the cloud, customers can make full use of Azure services to modernize applications at a pace that's right for your company. You can also think about using disaster recovery and business continuity. Customers can lean on AVS to establish remote access to data and apps in Azure. With the high bandwidth connections using ExpressRoute, you can recover quickly from incidents. The low latency networks also give fast response times to users when they've come to expect their applications to be up and resilient. With AVS, it's easy to replicate VMs, all your policies, and networking using familiar VMware tools. And the ease of recovery and replication greatly reduces the effort and risk by helping out bringing your environments back online. So then there's the speed and simplification of migration. So you don't need to convert these VMs to IaaS, or you don't need to convert your workload to PaaS in order to gain access into Azure outright. That tends to help out and speed up the transformation you're hoping to achieve. From there, you also gain access to application modernization tools as well. So you could make use of Azure Active Directory, you could make use of advanced analytics, or even AI to start moving you toward application modernization surrounding your VMware stack. Let's move into the deploy steps next. So these are the high-level steps when you deploy your environment inside a software-defined data center or an SDDC within Azure. You'll first deploy the AVS private cloud. From there, you'll create a virtualized network or a VNet within the environment. Afterward, you'll create an Azure Bastion host for access into the AVS environment on premises. You'll then create a gateway subnet on the VNet, deploy a VNet gateway, and provide an auth key to connect your on-premises environment into Azure using ExpressRoute. Finally, you'll connect your ExpressRoute to the VNet gateway. Fairly straightforward. Obviously, there's more involved, but this is the high-level overview of deploying it inside of Azure. From there, you'll want to connect VMware in Azure to on-premises. So then you'll have to take into consideration getting onto the jump box or the Bastion host you created during the AVS deployment. You'll then connect to the vCenter inside the jump box. From there, you'll connect to the NSXT manager, and you will enable global reach for the on-premises access. And finally, you'll configure the on-premises environment with VMware Identity Manager, which is the identify as a service offering from VMware, which provides single sign-on capabilities and user-based controls within a VMware environment. Of course, I'm oversimplifying this process a bit, as each step is a bit more involved, but the concepts are straightforward. You've got some configuration you need to handle on premises and some configuration you need to handle inside of Azure. So once you take care of both sides, you actually have a hybrid solution that extends your VMware footprint into your cloud provider of choice. Let's move into what the management looks like. So the beauty of running VMware in Azure is you and your team will be extremely familiar with all of the VMware tools and technology. After all, it's VMware on Azure. Using AVS allows you to create operational consistency for admins, since you'll use the vSphere client to access your cluster, plus all your VMs, and then the NSXT manager. Access to vSphere, HCX, and NSXT are also enabled during the private cloud deployment process in Azure. Credentials are registered in Azure to connect to those private hosts. Then there's an ability to easily scale the infrastructure to match business needs through the Azure portal. Another thing to note is if you can do it in the portal, there's a REST API equivalent, so you could even think about automating some of this scale if you need it. You can add new nodes as required to increase compute and storage during peak times, which provides you a lot of flexibility. You can delete nodes when demands are lower as well. The math is called out in the slide. You need a minimum of 3 nodes per cluster. There's a maximum of 16 nodes in a vSphere cluster, and then there's a maximum of 64 nodes in an Azure private cloud instance. Often, we show where the division of responsibility lies between the customer and Microsoft associated to the shared responsibility model related to Azure. The model itself is related to Azure all up. It looks somewhat similar. However, this chart focuses on the lines of responsibility for AVS itself. As you can see, Microsoft abstracts a lot of the ongoing maintenance, security, management, etc., leaving your company in charge of the things that matter most. guest OS provisioning, applications and virtual machines. Plus, you get to think through your own lifecycle process, and you can also bring your configuration management techniques into Azure as well. With this model, certain types of operational pains tend to go away by placing your platform on Azure and running your VMware vSphere infrastructure in the cloud. Let's move into the network architecture section next. Network interconnectivity between your Azure VMware Solution private clouds and on-premises environments or virtual networks in Azure enables you to access your private cloud. There are two types of AVS private cloud interconnectivity. First, there's the basic interconnectivity, which enables you to manage your private cloud with only a single virtual network in Azure. And then there's the full on-premises to private cloud interconnectivity, which extends the virtual network connectivity to also include interconnectivity between on-premises environments and AVS private clouds. At a high level, this is kind of the quick overview, so to speak. What's called out here in the slide is the basic interconnectivity. This implementation is best suited for AVS evaluations or implementations that don't require network access from on-premises environments. Think of this as maybe the starter version of interconnectivity and network access. There's logical express route based networking between a virtual network and Azure and a private cloud, which is highlighted here. The interconnectivity fulfills three of the primary use cases: inbound access to vCenter and NSXT Manager that is accessible from VMs in your Azure subscription and not from your on-premises subscriptions. Additionally, this provides outbound access to VMs to Azure services, as well as inbound access and consumption of workloads running in the private cloud. When we think about the full interconnectivity, you need to enable ExpressRoute global reach between a private cloud ExpressRoute circuit and an on-premises ExpressRoute circuit. An on-premises to ExpressRoute circuit is required to connect the on-premises environments to your AVS private cloud in Azure. This ExpressRoute circuit sits in your subscription and isn't part of the AVS private cloud deployment. The on-premises ExpressRoute circuit is beyond the scope of this conversation, but know that if you require on-premises connectivity to your private cloud, you could always use an existing ExpressRoute circuit or purchase one inside the Azure portal. Once you've linked this with global reach, the two ExpressRoute circuits will route network traffic between your on-premises environments and your private cloud. To enable the full connectivity, an authorization key and private peering ID for global reach can be requested within the Azure portal. You can use the key and ID to establish global reach between an on-premises circuit in your subscription and the ExpressRoute circuit for your new private cloud. The routing requirements for the solution require you to plan your private cloud network address spaces so that you don't overlap the IP space. This implementation enables the following use cases. You've got the hot and cold cross vCenter Vmotion and on-premises to AVS cloud management access. There's a third model as well. I have the asterisk sitting here on the slide. I'll talk through what the caveats are. So AVS supports VPN connectivity as a pattern for POC deployments as you're waiting for your ExpressRoute to come in, or maybe you just need the site-to-site connectivity. This would be a supported scenario. Unfortunately, VMware at the present time is not providing an SLA-based guarantee. Unfortunately, let's start that back. Unfortunately, right now, VMware is not providing an SLA-backed guarantee related to the HCX migration pattern over a site-to-site VPN. So this is a really great scenario to use if you're just starting in. And then if you don't need that full on-premises to Azure connectivity, you could think about using this solution as well. Let's move into what the migration pattern looks like. Similar to other native and third-party tooling, companies need to assess their VMware environment with something like Azure Migrate or Sizer. From there, customers have a better understanding of the workloads they intend to migrate. The migration approach can be done as a live migration, a bulk migration, or a cold migration using HCX Enterprise. Plotting out everything in this manner means customers have more time to identify all steps for workloads to reach full production. Of course, customers will want to go through several tests and reach that final validation phase. Microsoft encourages that aspect, as you need to feel confident the solution is viable for your company. You'll create the private cloud, move a few VMs using your preferred migration type, and hope to encounter no issues, as you will have worked very closely with Microsoft throughout the whole entire process. Once the POC is over, there's the transition to production phase where you perform the at-scale migration and adoption of the AVS platform. We offer up Microsoft Fast Track as an option if there is a need to help scaling what that environment would look like. You could also obtain support from certified partners in Microsoft's partner ecosystem to help as well. Azure Migrate now supports assessments for the Azure VMware Solution, providing even more options for customers to plan their migration path into Azure. Previously, Azure Migrate tooling provided support for migrating Windows and Linux servers to Azure virtual machines living in an IaaS world. Newer features now include database migrations, web application migrations, virtual desktop scenarios, and the Azure VMware Solution. So using the Azure Migrate Server Assessment tool, customers can analyze readiness, Azure suitability, cost planning, performance-based right sizing, and application dependencies for migrating to AVS. The AVS assessment feature is currently available in public preview. The solution supports up to 35,000 VMware servers in one Azure Migrate project as well, which seems endless. Hybrid Cloud Exchange, or HCX, becomes the tool to lean on here related to migrations. HCX Advanced is the default installation. It supports up to 3 external sites. However, if you want to migrate your environment from on-premises into Azure, you'll have to take advantage of the HCX Enterprise platform. So HCX can offer large bulk scale migrations of VMs, which is a really compelling story if your environment contains a lot of VMs or if you're living on an older version of vSphere. HCX also supports any vSphere to vSphere migration pattern, which adds extra functionality, not just a migration path into Azure. It's really the Swiss Army knife of the VMware environments related to migrations. HCX can be a part of a site pairing and disaster recovery, which means high availability will follow your app around regardless of any disasters, user errors, or equipment failure. HCX offers parallel VM migration threads as well, which helps speed up that process and helps it feel less like a single-threaded migration path in terms of everything landing in Azure. HCX does not require an IP address change, and there's no NAT involved either. So this really starts to become an awesome conversation with customers that may not need their IP addresses to change. I know I had mentioned when you talk about planning out your networking, you don't necessarily want the IP addresses to overlap. You can build out another network segment that accounts for your HCX migration paths and also relates to translating what that IP address will look like, so you don't have to think about picking up a brand new IP address when you land inside of Azure. Lastly, HCX provides a secure proxy for Vmotion and replication traffic to hopefully appease any sort of security-minded firms. So HCX Enterprise will allow you to extend that layer 2 networking so both environments have the same IP address. Now, this is a really awesome scenario because of the fact that you don't have to think through re-architecting or picking up a brand new IP address. Usually there's a little bit of time for everything to mesh together once you make that migration path into Azure. So in order to set this up, global reach should be configured between on-premises and the Azure VMware Solution. From there, all required ports should be open between on-premises and the AVS solution inside of Azure. You'll need one IP address for the HCX manager on-premises and a minimum of 2 IP addresses for the interconnect and network extension appliance. The on-premises HCX interconnect and network expansion appliances should be able to reach your vCenter and ESXi infrastructure in Azure. To deploy the WAN interconnect appliance, in addition to all of the networking you'll have to plan for up front, you'll need an additional /22 CIDR network to handle this. And I think you're starting to see now, this is why you can do the extension of that layer 2 IP address space. So really, I think the biggest piece here to factor in is do all of the homework up front related to your network planning. So in this demo, I'll walk you through what it's like being the admin for Contoso Health Services. Contoso Health Services is a longtime VMware shop that provides billing and other patient services to doctors around the globe. As a company, they're looking to Azure to help expand and modernize. So inside this demo today, I'll show you how easy it is to get started creating your first private cloud, how you can then use the existing VMware tools that you know and love to manage those private clouds in Azure, and how to take advantage of key capabilities of Azure, like our global footprint, the AZ CLI, with very little friction. So we'll start here by picking the solution itself. You'll have to provide the resource group. You'll need to specify the resource name, pick the SKU, account for the right amount of ESXi hosts, provide the vCenter admin password, confirm that password, and then you'll also provide the NSXT manager password. You'll confirm that password as well. And then you'll specify the address block, and you'll tie it to the virtual network that's already been deployed in Azure. And then you'll hit create. Now some time has passed. So you can see here, everything's been created. I can manage the connectivity once we go in here. I can take a look at the number of hosts. I can go configure certain components here. I can take a look at connectivity as it stands. So I can take a look at the express route connection. I can focus on HCX. This is where you configure the express route global reach. You can add certain things on. So right now you can add on VMware Site Recovery Manager. It's a BYOL license scenario. So if I want to go into my VMware environment, I'll go into the Bastion host, and I'll connect by providing my username and password. And once I'm inside this environment, you'll see I've got vCenter sitting here. So I can take a look at storage. This is the vSAN data store that gets deployed by way of the AVS environment. You can take a look at the networking. These are the different segments here over on the left. I can go in here to my NSXT manager and take a look at the different segments. I can also take a look at HCX. I've got 2 deployments sitting across the pond, so to speak. We can go in here to the content library. Take a look at the content library as it stands here. It's living in an Azure storage account, which is kind of a cool reality, a way to extend what you're already doing inside of AVS. And when you go into the storage account itself, you'll see the exact same thing show up here in the content library. So let's say I wanted to go the route of increasing the amount of ESXi hosts. I can do it in the portal, like so. It's pretty straightforward. Or I could lean on some automation tooling as well. We have the AZ CLI commandlet library. You can add different nodes. You can do administration. It's kind of a cool reality. It's hitting the REST APIs just like PowerShell would, or an ARM template, or even the Azure portal. So what it's doing here is it's going to expand the clusters. It takes a little bit of time here, and you'll see that the cluster has now been expanded. The cluster node count, I should say. So now we're seeing it at 4, which is pretty cool. So, in this demo today, I showcased how easy it was to set up your AVS private cloud. We were able to take a look at the vCenter environment, took a look at the content library, which showcases a way in which you can actually integrate the Azure environment into your AVS private cloud. And then we spent some time taking a look at the AZ CLI to see exactly how you could automate some of this as well. And we've arrived at the end of the session. Thank you.